So let's start at the beginning of this. Suppose you bought a 36-foot rope and you wanted to cut it into 4 smaller ropes of equal length. I think that's what it says. Yes. How long would each rope be? Okay, that's easy. The answer is, by the way, oh my goodness, come on, 36 divided by 4. 9. 9 feet. So, represent this situation as a multiplication and as a division equation. So, using multiplication, we could say 4 times 9 equals 36. As a division equation, we could say, help me out, 36 divided by 4 is 9. Now, that means exactly the same thing, right? And we have, the first one in the multiplication, we have 2 factors and a product, right? 4 and 9 are factors. 36 is a product. What do we call the parts of a division equation? So the first one is called the okay, the first one. And the next one is called the, no, we skipped the first one because you didn't know its name. The second one is called the divisor. And the third one is called the not sum or product or dividend. Quotient. Quotient. Okay? You remember those words? Oh, so the first one must be the dividend. Dividend divided by divisor equals quotient. Oh, I just don't listen to you anymore. I don't know why. Okay, so create a multiplication box to represent all of the equations above. Okay, so this is, I don't have a lot of room, but our multiplication box is super easy. 4 and 9, times those together, I get 36. What if we started with the answer? Could we use the multiplication box to get, what if we wanted to represent this as a division problem? So if I told you, we're going to cut the rope, 36-foot rope, into 4 pieces, can I figure out the other side? Yeah, I just use division. 36 divided by 4 is 9. Okay? Now I know that was super easy. Relax. It's going to get harder. We are going to do the same thing using polynomials. So, for this first one, 2x times 4x plus 5 is 8x squared plus 10x. So 8x squared plus 10x. And then we can do the same thing here, x minus 5, x minus 7. So multiply that together, then do the next one, and do the next one, and I will pause the video. All right, so now that you finished all of those, hopefully you noticed that the answer to each one of these products was the numerator in each of these. Right? So, we are going to look at how to divide polynomials. Can you take a polynomial and divide it by another polynomial? But before we do that, let's consider, well, actually, I don't think we need to. So let's look down at the first one. We're going to use the same multiplication box that we used before. So 2x, and then I'm going to make a box here, and you're not necessarily going to know how big each box is to begin with. Now you do, because you've already done the multiplication. But in future problems, just start with how many rows you need, and then add columns as necessary. So for this first one, I need to account for 8x squared, so I'm going to stick that in this box. Well, using division, what is the factor that goes on top? 4x squared. So 4x. 8 divided by 2 is 4, and x squared divided by x is x. Now, have I used up everything in the numerator yet? No. So I need another column, and now I stick this in that place. 10x. 10 divided by 2 is 5, and x divided by x It's just 1, so we don't need it. Now, have I used up everything in the numerator? So I'm done. Yeah, I'm done. So this is the answer to the division problem. So that might seem kind of strange. 8x squared plus 10x divided by 2x is actually just 4x plus 5. Does that make any sense? Why? Well, certainly, if you do the multiplication, you're going to get that product, and then you take that product and divide it by one of the factors, you should get the other factor, right? So what you're saying essentially is this is 2x times 4x plus 5, and we're dividing it by 2x, and the 2x's cancel, and I'm left with 4x plus 5, right? Okay, so let's do the next one. I'm going to put x minus 7, and again, I don't know how many columns I need, at least not yet. Okay, now I need to account for the x squared term, and the first term always goes in the top left box, x squared. So if that's an x squared and I divide it by x, what goes on top? X. Now what should I do? Can I fill in any more of the boxes? Which one? The bottom left one. How does the bottom left one get calculated? X times negative 7 is negative 7x. Now, have I used all of the values in the numerator? No, so I need to add another column. Okay. Now what do I do? Well, I need to account for this negative 12x, but where do I put the negative 12x? Yeah. Negative 12 is actually split into 2 pieces. And one of those pieces I already know. So back when you did the multiplication, this box and this box combine to be negative 12. And I know one of them is negative 7, so the other one must be negative 5. So I can put negative 5x there, and then what times x is negative 5x? Negative 5. And then negative 5 times negative 7 is 35. Does that account for the last term? Yes. So x minus 7 divides into that quadratic evenly. Okay? All right, next one. X negative 7. So I put the x to the third in the first box. I use my knowledge of division. What goes on top? X squared. Now I multiply negative 7x squared. And then I haven't used them all. I've used this one. So I add another column. How many x squareds do I need in that box? In the whole thing? I need negative 10x squared total. And I already have negative 7x squared. So how many more do I need? Negative 3. I actually need to take away 3 more x squareds in order to match this negative 10. And then once I fill in that box, I can fill in the top one, which is negative 3x. And once I figure that out, I can fill in the bottom one, which is 21x. And I haven't used them all yet, so I add a column. Now I need a 23x, and I have a 21x. So I need 2 more x's in order for this to match. So I put a 2x there, and that gives me a 2 on top, and those multiply to be negative 14. Does that account for everything? Yes, so I'm done. So the answer is actually x squared minus 3x plus 2. Okay? All right, the last one. 5x minus 2. So I'm going to put in the 15x to the third. That gives me 3x squared on top, which gives me a negative 6x squared on bottom. What do I need in order to equal negative 26x squared? I need to take away 20 more. So negative 20x squared there, which gives me a negative 4x on top, which gives me an 8x down here. And I need a 43, and I have 8. So how many more do I need? 35 more. So this is 35x, which gives me a plus 7 on top. And those multiply to be negative 14. Does that match the negative 14 I was hoping for? Yes. So this divides evenly. Okay? I'm glad you asked. What happens when it doesn't? Well, I have prepared this for you. Going back to the rope story. Before you actually cut the rope, you decide to measure its length, and you discover that it's actually 37 feet long. Okay? So you buy a 36-foot rope, and you're going to cut it into 4 pieces. But you say, what the heck, I'll measure it. And it turns out being 37 feet long. Can you still cut it into 4 pieces? Yes, but the catch is each piece will be slightly longer, and they won't be nice 9-foot lengths like they were before. So create a multiplication box to represent this situation. So in the box, so how long are they going to be? Let's not do inches. 9 inches, and how much more? 1/4 of a foot. So a foot. So 37 divided by 4 is 9 remainder 1. Right? Do you remember doing this in elementary school? 9 remainder 1. Has that ever made any sense in the real world? No. So each rope is going to be 9 feet long, but there's 1 foot left over. Well, where is that foot? It's cut into 4 pieces, and it's attached to the original 4 ropes, right? So this whole 9 remainder 1 garbage doesn't make any sense in the real world, because you actually cut the rope, and yes, there is 1 foot left over, but do you have a 1 foot length of rope lying around? No. You actually have a bunch of ropes that are 9 feet and 1/4. So the remainder is actually 1, and you said it, 1/4. So I could do this. It's 9 plus 1/4, right? Because each rope is 9 full feet plus 1/4 of an extra foot. Now, we use those numbers all the time, except we don't write the plus. We just do 9 1/4, right? But mixed numbers actually have a little addition sign in there that we don't use. It's not a multiplication sign, it's addition. Okay? Well, we can do the same thing with polynomials. If it doesn't go in evenly, we're going to end up with a remainder. But you don't want to say like x minus 3 remainder 7, because remainders are a mathematician's invention that have no bearing on the real world. So, at least not when you're cutting rope. Hey. So, what we're going to do is we're going to divide these, and we'll end up with a certain number, remainder another number, and we're actually just going to say plus remainder divided by the divisor. Okay, so 37. I'm going to put 4 over here. How many times does 4 go into 37? 9 times. Okay? But we need to have an extra 1 here. That might confuse you. Okay, so it's 9 plus 1/4. I mean, you get that, right? Oh, maybe this is how we'll do it. We'll do it this way. So we'll say it goes into 36 9 times. And how many times does 4 go into 1? What times 4 is 1? 1/4. So that makes a little bit more sense. And really, 36 plus 1 equals 37. So the answer is 9 1/4. That might be a way that makes more sense. Okay. So for each of these problems, I don't know how many boxes I need, but I know that there are going to be 2 rows because the divisor has 2 terms. So x and 3. I bring down the x to the 3rd. What goes on top? x squared, and x squared times 3 is 3x squared. So I took care of that term. What do I need in order to equal negative 2x squared? I have 3, and I need negative 2. So what do I do to that 3 to get to negative 2? Subtract 5. So I'm going to subtract 5x squared. Now what times x is negative 5x squared? Negative 5x. This times this is negative 15x. Add a column. How do I reach negative 19? I take away 4 more x's. Good. So minus 4x, which gives me a negative 4 up here. Multiply those together and I get negative 12. Is that the number I was looking for? No, so add a column. Okay. So what goes in this box to make me reach negative 20? Negative 8. And that is my remainder. Now, the remainders don't mean anything in the real world. I mean, I guess if you're counting M&Ms, if you have 37 M&Ms, everybody gets 4 and there's 1 left over. But who's going to leave that M&M, right? You're going to cut it in 4 pieces and hand it out. Hey. So what we do is we say plus, and then we write the remainder, negative 8, and we divide it by the divisor, which is x plus 3. Just like when we had 9, remainder 1, we changed it to 9 plus 1 divided by how many pieces of rope there were? 4. Because that remaining 1 foot gets divided into 4 pieces. So the answer is x squared minus 5x minus 4 plus negative 8 over x plus 3. Now the crazy thing is, if I were to graph this equation or this equation, you wouldn't be able to tell the difference. Okay? Which is the same as saying, is 36 over 4 equal to 9? Yes. This number and this number are equal. This one has just been simplified. Is 37 over 4 equal to 9 1/4? Yes. So why did we do that? Well, we're practicing skills that we'll need later on. So these two equations, you wouldn't be able to tell the difference. There is a very subtle difference that you wouldn't pick up on until I teach it to you. But those two are equivalent statements, with one exception. Okay. Actually, in that case, those ones are identical, in fact. There is no difference between them, but sometimes there is. All right, let's try this one. Oh, thanks. So 4x minus 3. Put in the 12x to the third. What goes on top? 3x squared, negative 9x squared, or x, yeah. Now, what do I need in this box to match negative 29x squared? Need to take away 20 more, 20x squared. So this is going to be minus 5x. This will be 15x. What goes in the next spot? 8x. So this will be plus 2, and that equals negative 6. So we're going to have a remainder. So I add a column. And what goes here to make it negative, or to make it positive 8? I need to take away 14 more. So minus 14. So the remainder is plus negative 4 over the divisor, 4x minus 3. Now, if you want to put that negative down there instead, that's okay. That works. Oh, okay. Forget what I said about negatives. You guys are so picky. There we go. All right. When you solve those on the back side. For some reason, when I teach this, kids lose their brain on number 1. How many rows does number 1 have? 1. So it's x, and then just put the equation in those places and figure out what those are. So this would be x to the third, 12x squared, and 6x. So this will be x squared plus 12x plus 6. Right, all I did was take an x out of all of them. So on those simple ones, if you can just do those in your head if you'd like. But when you run into a a denominator that's a binomial or bigger, you have to use the box because you end up with diagonals. Okay? All right, get to work.